We are reviewing geometry. So if we are modeling area formulas, we are looking at a square and a rectangle. We have the base, we have the height, and area is really how much space right here on this 2D surface is being taken up. So if I were to count the squares, I have 6, but I can also do 2 times 3 to get 6. So my area formula for squares, rectangles is area equals base times height. Your height forms a right angle, a 90-degree angle. When I'm looking at a parallelogram, we need to create that right angle to get our height. Our height cannot be this slant right here. We have the same formula as area equals base times height. All these area formulas are centered around the relationship between the shape and a rectangle or a square. So here we have a triangle where we're cutting it in half and we're going to reposition it where we can make a rectangle. So a triangle is half a rectangle, base times height. A trapezoid, we're going to cut in half, reposition where we have to add the two bases, and multiply the height. So we have area equals 1/2 times base 1 plus base 2 times the height. And now we are going to solve some area of parallelograms problems. So the base and the height always form a right angle. So when we're looking for the height here, this is our height. We're at this right angle, not this. This is extra information. So I'm going to write my formula first. I'm going to substitute what I know. The base is 8.05. My height is 2. And I'm going to solve this. So my area is 16.1 centimeters squared. Number 2, I'm going to find the height when the area is 245 square inches and the base is 12.25 inches. So I'm going to write my formula. What I know. And then I'm going to solve it like a one-step equation to figure out the height. So now I need to move this decimal point twice, which means I need to move this twice. My height is 20 inches. All right, classifying triangles. We can classify triangles two different ways, by their side lengths and by their angles. If we have all side lengths are equal, they are the same, it is called an equilateral triangle. If we have two sides are equivalent, it's called an isosceles triangle. If three sides are all different, it's called a scalene triangle. If we are classifying by angles, we have all angles are less than 90 degrees. This is called an acute triangle. We have one angle that is 90 degrees, that is a right triangle. And we have one angle that is greater than 90 degrees. This is an obtuse triangle. Properties of triangles. So we have the triangle inequality theorem, which says the two short sides of a triangle must be longer than the or greater than the longest side for the three sides to form a triangle. The sum of all the angles equals 180 degrees, and then the greatest angle is across from the greatest side length. So number 8 says determine if the given side lengths can form a triangle. So I'm going to take the two shortest sides, which are 5 and 7, and are they greater than 15? No, so this cannot form a triangle. All right, in triangle HJK, okay, I'm going to draw this. Let's make it a little bigger. Angle H measures 80 degrees. Angle K measures 76. Order the side lengths from least to greatest. Okay, first I need to figure out what the missing angle is. So that means my missing angle, solving this like a one-step equation. So this is 24 degrees, so least to greatest. So my smallest side is HK, because it's across from my smallest angle. Then HJ, and then JK. So the area of a triangle is 1/2 base times height. Remember, we always look for the right angle between the base and the height. So we have area equals 1/2 base times height. We have 1/2 times 4.5 times 2. 1/2 times 2 is 1. So my answer is 4.5 centimeters squared. Now we have a backwards problem. The area of the triangle is 48 squared centimeters. The base is 8 centimeters. Write an equation and then solve for h, the height of the triangle. So area equals 1/2 base times height. 48 equals 1/2 times 8 times my height. 1/2 times 8 is 4. And we solve this just like a one-step equation. So my height is 12 centimeters. Area of trapezoids. So my formula is area equals 1/2 base 1 plus base 2 equals height. Remember, the bases have to form a right triangle or a right angle with the height. So we need to make sure we're using the correct numbers. It says find the area. So this is my height. So these are my bases. I ignore this. This is extra information. One half times 18 is 9 times 3, is 27 centimeters squared. The height of a trapezoid is 7.25 centimeters. One of the bases is 15 centimeters. Write an equation that can be used to solve for the other base. So we do not need to solve this. We just need to write an equation. So my formula for area for a trapezoid is this. Area, we don't know. Base 1, 15, don't know. Base 2, and my height is 7.25 centimeters. So that's my equation. Volume of rectangular prisms. So our formula for volume of rectangular prisms is V equals big B times H. Big B means area of the base. This is not really going to affect us now, but it will affect us more when we talk about triangular prisms in 7th grade, where your step of solving for big B is going to change depending on the type of prism. But in 6th grade, we just talk about rectangular prisms. So what is the volume below? And it is a cube. So a cube bases are squares. And what do we know about squares? That all sides are congruent. They are the same. So this is my volume formula. And then we also need to solve for big B first. So my base is a square. My formula for a square is base times height. So that is 5 times 5. So the area of my base is 25. I'm going to plug that back into volume. So 25 times 5. So my volume is 125 centimeters cubed for volume. Number 15. What is the volume of the rectangular prism below? My base is here. You can also use this base. Doesn't matter in a rectangular prism, but in a triangular prism it would. We have V equals big B times H. Big B, we're going to do 2.05 times 1, which is 2.05. We're going to plug that back into volume. And if you multiply those two together, 2.05 times 8.2 is 16.81 centimeters cubed. Thank you for watching.